Welcome, everyone. We'll give it a few seconds and then we'll get started. Let everybody join. Okay, we'll get started. Hi, everyone. On behalf of the Southeast New England Program Network, welcome to our webinar titled The Watershed Production Standard for Clean Water, Cool Communities, and Smarter Growth, featuring our speaker, James Houle, Director of the UNH Stormwater Center. The purpose of the SNEP Network webinar series is to showcase the work of our partners and share out regional case studies and emerging topics and resources relevant to the SNEP region. We are grateful to have the opportunity to share this important work with the communities in our region. My name is Leah Soloway. I'm the SNEP Network Coordinator located at the New England Environmental Finance Center, and I'll be managing logistics for today's program. Before we get started, I'd like to introduce and provide you all with a little background about the SNEP Network and the SNEP region. The SNEP Network is a technical assistance and training program that is led by the New England Environmental Finance Center, which is a regional technical assistance provider for EPA Region 1. The SNEP Network's mission is to empower communities to achieve healthy watersheds, sustainable financing, and long-term climate resilience through the management of stormwater and restoration projects. We focus on building local capacity by providing no-cost trainings, webinars, and hands-on technical assistance to communities in the SNEP region. The SNEP Network is funded by the Southeast New England Program, or SNEP, which is a bi-state initiative of EPA Region 1 that supports clean water, healthy ecosystems, and sustainable communities across Southeast Massachusetts and Rhode Island. If you'd like to learn more, please visit our website, snepnetwork.org. And before we begin the webinar, there are a few logistics to keep in mind. First, everyone will be on mute to ensure audio quality. At the end of the webinar, there'll be a Q&A session. You'll be able to ask questions by typing them into the Q&A box on your Zoom control panel. We look forward to answering questions, so please type them in at any time. This webinar is being recorded, and the recording, along with associated materials, will be sent after the webinar to participants and will be available on the website. Today, you'll be hearing about the Watershed Production Standard Toolkit, a resource that was funded and brought to fruition by the SNEP Network. The SNEP Network partners saw a need to translate EPA's research of the Watershed Production Standard into digestible materials that are understandable and accessible to a wide audience. The SNEP Network hired VHB to lead the development of this resource alongside SNEP Network partner UNH Stormwater Center and the SNEP Network's Low Impact Development and Nature-Based Solutions team to serve as the advisory group for this project. The toolkit was completed in the fall of 2025. And now I'd like to introduce SNEP Network partner James Houle of the UNH Stormwater Center. He will provide a broad introduction to the Watershed Production Standard Toolkit, which the SNEP Network partners are rolling out this year. And thank you, Jamie. I'll hand things over to you.
Great. Thank you, Leah. Okay. All right. So hopefully you can see my screen. You can come off mute if something is not showing. Otherwise, I'll just continue. It's my pleasure, and it's actually an honor to be able to present to you kind of the work over the last couple of years of the network. And we've been working on what we're calling the Watershed Protection Standard Toolkit, essentially a toolkit of materials to help municipalities and engineers implement what we're calling the Watershed Protection Standard. So this might be a little new to you, this term Watershed Protection Standard. In other states or regions, this is also known as the retention standard. So an on-site retention standard or a groundwater recharge requirement. So that might be a little bit more familiar to you. We called it the Watershed Protection Standard because the tools and the toolkit are actually accessing powerful modeling, continuous simulation modeling that was performed by EPA Region 1. And I'll talk a little bit about that study as we get into it. So yeah, it's great. Welcome. Really looking forward to presenting this. As far as acknowledgments, I had the honor of presenting this, but in no way am I responsible for this content. It was really a work of partners, which the network supports and provided funding for, including VHB, our technical lead on this, as well as Mass DEP, Roca Communications, the New England Environmental Finance Center, RIDEM, and the Stormwater Center. So thank you to all those individuals. The real emphasis here is because um, as we see our rainfall precipitation patterns change, we're seeing kind of dramatic stressors in addition to probably the number one stressor in New England, which is land use change. So we see more water, and we're trying to mitigate the impacts of that in our urban centers, and then we're seeing the pollution attendant to that, mostly nutrient pollution, which we're trying to control so that we have fishable, swimmable rivers and lakes and water bodies. And we're also seeing on the other side um, areas of drought. So last year around this time, I think we were just entering into a pretty profound drought period, which threatened, water use and water supply. So these are the challenges that the Watershed Protection Standard was really developed to address. I do want to say that we didn't make this up. If anything, we are also a lot of this, the basic science here was done by EPA Region 1 and the SNEP program, the Southern New England program, um, a few years ago. It was the Taunton Holistic Watershed Management Study. So you can, I'd encourage you to go read the documentation. It's a great study. What we're trying to do is give it legs and give it a space to enter into the pragmatic realm of pollution control and water management in our communities. And that's really what the Watershed Protection Standard is about. One of the most interesting graphics from that study, we tried to make it a little bit more enticing, is this. This is what we call a flow duration curve. And really a flow duration curve is simply looking at the water levels in an adjacent stream and how that changes over time. There's natural variability in that stream, which is shown here by the pre-development curve, and hopefully you can see my cursor. So there is already inherent natural variability in the stream and the stream levels. And so we're showing this pre-development flow duration curve because that is sort of a design target. So much like everything else, we're using pre-development hydrology as our standard to design towards as we experience land use change and development. The metric that we're trying to always meet is that pre-development, in this case, flow duration curve. So you can see in this pre-development curve, if you just pay attention to that curve, and we contrast that with the post-development. So what happens to that that flow duration curve in a post-development scenario as land use changes, as we replace forests and meadows with houses and shopping centers. Obviously, that has a dramatic impact on the hydrology and the resultant stream flows. And so we're using the pre-development condition as the baseline. We can see two fundamental things, even in the baseline condition. We see these areas of high stream flow, and those are natural flood areas. And then we see these lower flows. When we contrast and we overlay this with the post-development flow duration curve, we see these gaps, these two gaps on the ends. So on the high end, we see an increase of flows. So that is more than the system can handle. And, traditionally, when it floods, we have intact floodplains that, just temporarily hold that water while we are experiencing these times of what we call an echo surplus. So this is a surplus of water. This is very natural. And, natural lands have a pretty direct way of dealing with it. But as we change in the post-development condition and we harden our landscapes and we deliver quicker, faster flows to the receiving water, its ability to respond and adapt is minimized. And we see that in responses to this eco surplus and, erosion and stream instability. And then we also see this as we experience this as flooding. So where the landscape can no longer withstand that eco surplus, we have flooding conditions. On the other end, we have this eco deficit, or this lower than normal flow in the stream. And of course, this is very important from a water supplies perspective. And this is also very important to the number of critters that also utilize the stream, our fish and other aquatic organisms. Um, Times of eco deficit means very, very low stream depths, and the survivability of some of these aquatic species is then threatened. So, this is the impact of climate change. Sorry, not climate change, of land use change. And this is what we're trying to address through our watershed protection standard and management strategies. So why the watershed protection standard? Really, it's because we recognize that our pipes aren't getting any bigger. Land use change is causing these increases in both the extreme events, the eco surplus, and on the supply events, these eco deficits. It's causing problems on both sides. And the whole idea is to address that and utilize development to work in our favor and to help build resilience within the community. This in turn saves money over time. I think one of the big uncaptured costs that communities face and municipalities face is the direct impact from these various flooding and drought events when our existing infrastructure is challenged by these land use change patterns. And I mistakenly said the word climate change. I'm not exactly sure why. The threat here, I just want to be clear, is really the land use change. And in a lot of senses, this is sort of what in the stormwater world has been one of our biggest challenges. So we know precipitation patterns are changing, but the impact of those pales in comparison to the impact from these land use changes. And I'll explain a little bit about that with some data. Also, we know that current standards aren't enough. So I think as you peruse through and look at either the Taunton study or the tools in the Watershed Protection Standard toolbox, that will become abundantly clear that what we're doing now and our groundwater recharge requirements that were developed over 2 decades ago are just not really holding up to the dramatic impacts that we're seeing, certainly now and into the future. And so this is a way to balance that and minimize the impacts from these land use changes while still preserving the integrity of our water resources, right? Which in this area are pretty significant. If we didn't have fishing and swimming and all those recreation opportunities within our rivers and streams, it would be a much, much different place. I also want to stress, and hopefully by the end of this, you'll agree that this is practical and doable by engaging and utilizing up-to-date modeling standards. We are actually making this easier to design for than it ever really was. So hopefully this presentation will stress that as well. All right, just to demonstrate some of the impacts here. We're looking at a typical town, and this is data that Mark Voorhees put together from all the data in the Taunton study. And we're looking at a typical town, say in the Taunton watershed in Massachusetts. And you can see the baseline, the 2016 baseline, and we're looking at various land uses. And then looking at projected changes over time. So if we extrapolate out to 2060, I would say land use change is a lot like, I think I can pivot here and talk about impervious cover, because what you're seeing here is the changes in impervious cover. So it's not necessarily the land use change that's the most dramatic impact. It's the land use change associated with the increases in impervious cover. And I would say impervious cover are kind of like taxes. We never see them go down. The amount of impervious cover is always going up. And of course, if impervious cover had a currency, it really would be the changes in hydrology through urbanization. So robbing the streams of base flow, robbing the groundwater resources of recharge. And so this is really the direct impact that we're trying to address here. So if you're looking at these numbers, typical town over the next 30 years or so, we're seeing a dramatic increase in impervious cover. Not unexpected. Again, not something that, I mean, these trends are pretty predictable. We're not seeing our population go down. Obviously, New England is a vibrant and great place to live and work and play, and we're seeing that reflected in development pressures. So this is one of the fastest growing areas. And so we see that through these increases in impervious cover across these land uses. So we're seeing a large increase, probably disproportionate increase in residents. So a lot more people wanting to move into this area, and that puts pressure to build homes and roads and parking areas and things like that. So these projected increases in impervious cover from 2016 to 2060, it's going to add about 1,460 or so acres of impervious cover. And now and then the source of information is down here if you want to look at that. I think we'll provide these slides too as a PDF. The other thing I want to talk about is our threshold, because this is an important component. You can regulate development, but if you're only regulating the largest of the large developments, your ability to impact for change and mitigate the impacts of this land use change are going to be limited. And so this is from a study we did in the Oyster River watershed, so a small watershed in still coastal New England, but in New Hampshire. And what we saw is of the existing impervious cover, if we looked at different trigger thresholds, what size of lands are being regulated. You know, if we go with the 1 acre de minimis or some close to 40,000 square feet, we're only grabbing about 30% of the actual development. So the biggest of the big developments are going to be addressed. If we use something a lot more protective, like 20,000 square feet, then we're addressing 50%. If we're using something like 5,000 square feet, then we're addressing about 80% of the development. That means only 20% of the developments are flying under the regulatory radar anyway. So, and then you can flip that on its head. If we're only managing large developments, then the vast majority of the land use change is going unmitigated. So again, if we're looking at these as a challenge to be addressed, and we're looking at impervious surface and its impacts to not only our water, but our water uses as well, something that needs to be mitigated. And we want to make sure that we're using development in a way that builds resilience, because our pipes aren't getting any bigger. You know, our pipes, if we look across the range of these anticipated increases in impervious cover, this is not going to be associated with larger culverts, right? A lot of our culverts are already in the ground. They were sized with old, outdated rainfall frequencies, and probably sized for return events with return intervals that are far too low, that we're seeing increase over time. So the best way to build resilience in that system is to implement stronger regulations. And this graph here, a little busy, but I just wanted to show the impacts from a groundwater recharge, which is in the light blue, and the runoff volume from these land use changes, in particular, the changes of impervious cover. So we can see if we start all the way on the left here, if we look at that increase of 1,740 acres of impervious cover, and we don't do any management, that's going to result, if we look at the increase of, it was, what was it, around, it was more like, sorry, I'm going back, 1,463 acres of impervious cover. That's going to yield an increase of 1,740 million gallons of water per year. that are going to be discharging to our infrastructure, our existing culvert network and stream network. So, that's going to be certainly a challenge for those systems to respond to and to adapt to. And then we're going to also experience a loss of recharge. So a deplenishment of our water resources, our groundwater resources that we rely on for drinking, and we rely on for base flow to our streams. And then you can see across the range of development scenarios, if we're managing 30%, so if we're moving forward with, these thresholds or trigger thresholds for regulations of 1 acre or more, then we're utilizing the watershed protection standard, we're going to have impact on these, obviously. The idea is to get to a point where the management is enough so that we're limiting the amount of flow that is challenging our existing infrastructure, and that we're also increasing and replenishing our groundwater supplies. So again, you want to choose something on this end of the curve that's far more protective of your existing infrastructure, because we know that means saving money on costly repairs and upgrades, and also that's protective enough so that you're replenishing those groundwater sources and replenishing drinking water and base flow. So again, I just want to state that none of this is really made up. It's really taking existing information from EPA Region 1, and it's trying to put it into kind of a pragmatic scheme for to be included in regulations. The goal is to match pre-development hydrology for the most part. And again, that's all based on that initial study that looking at the flow duration curve. So we're trying to limit the migration of nutrients off of developed lands, and we're trying to also mitigate that excess runoff as well, so that it doesn't degrade our receiving waters. And then I also want to point out, because this is utilizing up-to-date modeling techniques like continuous simulation modeling, it makes it more practical and kind of more implementable. So, this is just a graphic from utilizing the performance curves that are embodied in the Watershed Protection Standard and looking at it like a surface infiltration style system, looking at a range of different soil types. And if you wanted to do like a infiltration of a 2-inch runoff depth, we're not sizing these systems to hold that statically. We're using the dynamic aspects of the model to create a physical storage capacity of these systems that is far more manageable than using sort of the more static NRCS style hydrographs and coupled with different precipitation depths. So, if we're talking about the Watershed Protection Standard is trying to advance something like a on-site retention of the 1 inch, we're not talking about 1 inch static retention across the board. This is very dynamic, and it uses the power of the updated modeling tools to appropriately and optimally size these systems. So if we want to meet the Watershed Protection Standard with an infiltration system on an A soil, we're really only sizing it for like a 0.4-inch rain event. Obviously, if we get to the D soils, these are going to be larger. But again, it's not going to be like sizing it based on the type 2 NRCS distribution, where all the rain comes between 11:45 and 1 p.m. in a 24-hour event, which almost never happens. All right. So now I want to take the rest of the time to kind of jump into the Watershed Protections Toolkit. And there's a QR code here if you need to locate the site, but I'm just going to jump off this PowerPoint and now go to the SNEP Network website. And we tried this out earlier. Hopefully you're seeing the website. Again, if you're not, let me know somehow. So now I've magically transported you to the SNEP Network website, and the Watershed Protection Toolkit is under the Resource Hub. If you go down to SNEP Network Tools and Resources, we're all the way over here at the bottom. So click on that. And this is it. So what is it? It's a series of information and some infographics that can help you build a case in your community for advancing and adopting the Watershed Protection Standard. So I kind of went over this already in a little bit more technical detail. This kind of demonstrates sort of what we were just talking about with those bar graphs. No treatment, you have this dramatic increase in runoff and a decrease in water supply. And as you're advancing the Watershed Protection Standard at reliable and reasonable thresholds, you're mitigating these impacts from the using development and redevelopment as a kind of way to enhance and build resilience in your community. And if you scroll down, this gives you the background. There's that graphic that we just talked about. And then you get down to the actual toolkit. So there's fact sheets. If you need to work with your council or work with your planning board in order to build a case for this, you can access some of these fact sheets. I'm not going to go over these as much. It's more targeted for a probably not an audience that maybe it isn't up to date on all these things that we've been discussing. So that should help you out. Promotional handout as well. So these are just handouts and tools that help translate the science to build support. And I want to focus on these three things to end this. One is the template regulatory language. So if you click on this, what it'll actually download is draft language. And again, hopefully this is sharing. If you are not seeing the regulatory language for adopting the Watershed Protection Standard, let me know somehow. Hopefully this works. But it is essentially draft language that you can copy and paste into your site plan review regulations or your stormwater ordinance. So, this is what you need to update your regulations with. So it gives you step-by-step ways to adopt the standard. And so that's a great resource for you if that's something you want to pursue. Also, we've developed the checklist. So again, a lot of communities have developed checklists already to meet your updated stormwater regulations. And we just developed a checklist that's commensurate with all of the things required under the Watershed Protection Standard. Again, in and of itself, what the Watershed Protection Standard really requires is meeting that pre-development hydrology with an on-site retention requirement. And after I go through some of the site examples, we've also developed a calculator on our website that will help with that. So what the calculator does is it calculates the size of the system you need to meet the pre-development hydrology. So again, if we go back to those slides and you think about those slides I was just covering, you need it uses these performance curves to appropriately size your stormwater controls to meet the targeted goal. And that is the equivalent of a 1-inch kind of retention. So if you're on an A soil, your retention requirement or your physical storage capacity will be about 0.4 inches. That's pretty manageable. Remember, a decade ago, we used to use the water quality volume as the sizing, and some people even used 1.2 inches. So 1 inch effectively is the water quality volume. Then most of our control measures were designed to statically hold um, the 1 inch water quality volume. So as we're moving into these more optimized um, sizing criteria, adapted from the EPA performance curves, we have the ability to kind of refine the sizing of these systems, making it more pragmatic, taking up less space, and taking advantage of the power of the dynamic modeling tools. So this checklist is there when you adopt the standard to help develop and update your probably existing checklist to make sure that things are conforming. And then I just want to end with the site examples because I think these are probably the most useful component of the Watershed Protection Standard. And then again, hopefully this is it's loading for me right now. There. Hopefully you're seeing this. What these site examples are we took essentially existing land uses and modified these sheets to show and to demonstrate how you could potentially meet the Watershed Protection Standard. So we see these sheets being useful to planning boards or conservation commissions that are trying to manage development in their communities, and probably also useful to engineers and site designers that are trying to meet the watershed, things like the Watershed Protection Standard with different design strategies. So here's an example of a low density residential subdivision. Hasn't fully loaded yet. Yes, the issues of live demonstrations. Apparently, my internet bandwidth is struggling right now. So this is the example of low density residential subdivision. And what these design products do is, it gives you examples of how you could meet the Watershed Protection Standard using things like swales and bioretention systems, maybe requiring things like setbacks or downspouts that are taking advantage of impervious cover disconnection, so not directly connected to the road, maybe discharging to vegetated areas in the back. So all kinds of different examples of how this could be implemented on a very a site level. On the bottom left here, we have kind of a closer look and with actually identifying the stormwater controls. So again, the major control here is a bioretention coupled with a bioswale, but you have other things like impervious cover disconnection from the back of the roofs. You have permeable pavement at the turnaround spot potentially, and even dry wells to manage runoff from some of the parking areas. All this is calculated in the bottom right chart. And again, it will go over the amount of impervious area and then the sizing of the different structures and the overall achievement of the runoff reduction requirement. So all this is calculated. And like I said, at the end, I can show you a calculator that will help do this for you. So we've done everything that we can to make this, again, more pragmatic to implement from an engineering or design perspective and more pragmatic to review as well. We're not going to ask you to review the continuous simulation modeling results. I have enough trouble going through 640 pages of output files from HydroCAD. That's really difficult. It's a high bar if you've ever reviewed someone's stormwater report. What this does is it creates really consistent approaches to calculating this that can be used throughout the SNEP region and actually throughout the New England region, to be honest. All right, so that's an example of a low density. Here's an example of a large commercial property and different things you can do. And again, it has the same sort of format. Um, and you're just looking at a different land use. So obviously for commercial areas, the structural controls are going to have to be larger and more of them. So we're implementing infiltration basins, gravel wetland style systems to manage the nutrients, subsurface infiltration system, and other control measures within the median to meet this watershed protection standard. But so these are designed to give you um, depictions of how this can be done and without really limiting development. So we're not hanging up a sign saying no more development. We're saying let's develop smarter and with up-to-date tools and toolboxes. Here's another example of a large industrial property in different ways they could meet the watershed protection standard. And again, everything is laid out the same way. Here's an example of kind of an institutional property. So we have commercial, institutional, industrial. And then finally, there's a more high density residential development, which would go over how to manage all this. So hopefully these will be useful to you. All available, again, through the SNEP Network website. You can download these and peruse them at your leisure. I'm going to end here just to leave time for some discussion. And I also wanted to show you the calculator as well. So if I go to the UNH Stormwater Center website, and hopefully this is continuing to share. No one's told me that I'm talking about something I'm not showing yet. We go to MS4 resources. I think this is what the calculator is. Yeah, we have the WPS calculator here. We should also probably put it on the SNEP Network site and make it part of the toolbox as well. So if you click here, you'll have to download it on your own. I apologize for that. The benefit of always going through the Scholar repository on our UNH site is that you're always going to get the most up to date. You're not going to have to deal in our old website. We're always intervening because people are using outdated tools. So that'll never happen. The downside is you have to download everything. So is somebody seeing an Excel sheet?
Yes, we can see it.
All right, thank you. This is great. Either Zoom has really improved its tools, or we used to always have to like stop and reshare every time we kind of switched out the screen, but this has been going well. So here's the watershed protection toolkit. So essentially, if you provide an impervious area like a 1 acre, I have 1 acres of imperviousness to treat, it's going to tell you the design storage volume that you need. So it's going to tell you how to size your different systems. In this case, it's a bioretention with no underdrain, so it's infiltrating or elevated underdrains, but you can choose from a range of different structural controls that are modeled. And so this is all accessing all that continuous simulation modeling that was produced by the EPA Taunton study. And it's going to tell you how big to build your system to meet the watershed protection standard. You can change the infiltration rate. So, for A soils, obviously, it's going to shrink the amount, the size. And if you're on more restrictive soils, the size is going to increase. But regardless, based on the treatment system that you select, it's going to tell you, how big that system needs to be. And we have other, I think, lectures on these calculators, exactly what the design storage volume is and how to calculate that. This is also directly in the MS4 permits for Massachusetts and New Hampshire, and in Appendix F, if you need a refresher on how to do this. Notice there's not gravel wetland here. Now, gravel wetland systems we can incorporate into our treatment areas, but it has no ability to infiltrate water. The requirement for gravel wetland style systems is you're in restrictive soils that don't infiltrate. So gravel wetlands are great when you have low porosity soils and you still want nutrient control, but it doesn't give you a recharge component. So only the systems that have an infiltration component are going to be represented here. And then the last thing I would say is impervious cover disconnection. You can see the sizing disappears, and it's because the impervious cover disconnection is based on a ratio of, it's based on a soil type, and it's based on a ratio of impervious area to impervious to pervious. So I'm not exactly sure where that ratio gets put in at this point because I'm just kind of on the fly, but oh yeah. I guess it would be a ratio 0.62, but there's got to be somewhere where you can choose the ratio of pervious to impervious to pervious. I guess that would be for another time. Regardless, we've developed this calculator to help you kind of both meet it from a design perspective and to review it from a regulatory perspective. So I think I'll stop there and open it up for questions. I did leave 19 minutes for questions. So
Yes, thanks, Jamie. Yeah, we can start with some questions. I already see some in the Q&A box, and if the audience has questions, please type them into the Q&A box in the Zoom control panel. Jamie, the first question refers back to a slide you shared earlier on, I believe is the impervious cover slide. The question is, what are the units on this table? It's one of the first tables you showed us.
okay. So I'm going to make sure addressing the right slide. I think it's this one. No, I'm usually good about providing units. So the units are included in the title. So this is increases in impervious cover. So this is acres of impervious cover. So I apologize, the acres is not there. So in this case, for transportation, we're seeing over the projected increase 467 additional acres in transportation land uses, impervious cover associated with transportation land uses.
Okay, yeah, that answers that question. Thank you, Jamie. The next question, how do we overcome the perception that large lots will provide environmental conditions services that need the kind of regulation and land use changes that are proposed here?
Can you read that one more time?
Sure. How do we overcome the perception that large lots will provide the environmental conditions services that need the kind of regulation and land use changes that are proposed here?
How do you overcome that perception that they can't or they can?
Um,
So
yeah.
I guess I don't know exactly what the question is referring to, but one of the misconceptions might be, um, that because this happened originally with like impervious, permeable pavements. Right? All of a sudden, we had this really remarkable stormwater control that could do a tremendous job of managing and mitigating the altered hydrology from developments. And since we had this new technology that could do such a great job, now people were anticipating, well, why does this area need to be protected? We can just build it out and then we can use these great technologies. So this is just one part of your regulatory toolbox. And I think we had provided a lot of information back then that there's no way these stormwater controls and these types of standards should replace good zoning and good kind of land use regulations to begin with. So you should be preserving wetlands. You should have setbacks around those wetlands. This is not replacing that. And I would hate for that perception to get out there that, oh, we can just ignore time-tested, good zoning strategies and conservation strategies by utilizing these up-to-date stormwater controls. Another thing I'll usually tell people is when you're arguing about your stormwater controls, you already have lost the battle with respect to, you've already given that land up for development. So if you're on a aquifer protection area and people are talking about and planning for, a large housing complex, and you move to managing that stormwater, you've already given up on the benefits of protecting that area from a aquifer protection perspective. So we still need good zoning and good regulatory standards around what places can be developed and what places shouldn't be. So, and this does not replace it. All this does is as you move into the discussion around a said development, this is mitigating the impacts of that development to the best, according to the best available science. I hope that answers it. And I don't know if I interpreted that question correctly, but that's kind of the double-edged nature of this that I'm glad I had the opportunity to address.
The next question, Jamie, can you anticipate conflicts with septic system requirements in these low density developments?
It's a good question. Can I anticipate it? Yeah, I think if obviously we're going to be relying on infiltration, so you'll want to abide by the same kind of separation and setbacks from septic. And then you might have to assess, and we always, with any infiltration, we're always assessing the hydraulic gradient, right? Because we don't want an infiltration system that's going to flood someone's basement. We don't want that problem. So usually there's going to be some assessment of the hydraulic gradient. And just like you don't want water intruding into someone's basement, you also don't want to be intercepting or influencing point of view septic systems. So yeah, I think there's going to be, especially if you're building on septic, there's always going to be considerations around separating these stormwater features from your your waste disposal features.
Another question we have here, have any communities already implemented the regulatory language?
That's a great question. This is relatively new. We just put it into our New Hampshire stormwater manual, which came out in February. And I think we're still waiting on like the new MS4 permit to come out for Mass. We're still waiting on the new MS4 permit to come out for New Hampshire. So it's a really good period, I think, to consider implementing this. I would say it is consistent with the Mass draft permit that was out, and it's consistent, at least in theory, with the new Mass handbook. Although it uses some different methods. I think the new Mass handbook, they advanced a 1-inch retention standard that they have discussed reducing down to 0.8 inches. And we're talking with them about, potentially allowing the use of these calculation tools in order to meet that and not relying on the type 2 or type 3 distribution. So I do not know of a community that's adopted it. I would say it's relatively new. And if you want to be the first, there are great resources for you. So in addition to the SNEP network, we also have NEWIN, which the acronym is evading me. Help me out if you can, Alex or Leia. It's the New England Water, what's the IN? Infrastructure Network. So that's also run by the New England Environmental Finance Center, and they are providing free technical assistance. So go ahead and sign up and say, I want to be the first community to adopt the Watershed Production Standard, and a team of very qualified, um, eager individuals will help you out.
And we can send information in the follow-up email with links to how to request assistance. The next question and this was when you were sharing the calculator, is the model taking slope into account or just area, soil type, and treatment system?
Yeah, good question. Mark is on the line. I do not believe the model takes into account slope, but Mark, do you know the answer to that? Because these are
Um,
just hydrologic response units, right?
yeah. Um, in the development of it, it does factor slope in.
Okay.
But it's a slope of three. It's a relatively minor slope, three or so percent. But we do have the HRU modeling units that were done for three different levels of slope from low, medium, and high. But the analysis that the Watershed Protection Standard is based on is a relatively minor slope.
Okay.
I think off the top of my head, it might be 2 or 3%. Thanks.
The next question was asking if we can provide a link to the calculator, and we'll make sure to provide the link to the calculator. And I like, Jamie, your suggestion to add it to the SNEP Network website as well. The next question is there a glossary of abbreviations?
Yeah, that's a great recommendation. I know we always forget about the glossary, right? That's the one thing. So we just updated the New Hampshire Stormwater Manual and we didn't have a glossary in there. So that we added. I don't know if the toolkit has a glossary. It may. And I think I remember seeing something like a glossary. If it doesn't, it certainly should. Because yeah, there's a lot of new acronyms and there's a lot of new things like design storage volume. Where the heck did that come from? And um, I apologize if we don't, and I will plead forgiveness for my ignorance if we do.
The next question is referring to in the rendering on slide 3, there was a significantly large parking lot impervious surface. Is it not advantageous to require more infiltration structures within the parking lot to better distribute the areas of infiltration?
Yeah, I won't go back to that, but absolutely. And in no way are these meant to be, this is the one way to design, a large commercial parking lot. Uh, I'm hoping that the era of, um, like pipe and pond design is over and we're transitioning to the new enlightenment of all kinds of creative ways to do this better. I will not argue the merits of breaking up pavement or utilizing different and better strategies. I think what we are trying to just depict is that this is doable even in large commercial developments. And here's like one strategy, but in no way is that the only strategy. And like I said, I hope that we're marching into a new era of enlightened stormwater management that's going to help us as we progress.
The next question, the draft regulatory language recommends municipalities in urban areas require a land disturbance permit for disturbance of any amount of land for which capital cost of proposed improvements is more than 30% of the appraised property value. And have any municipalities adopted this approach?
Yeah, this particular clause, so there is a redevelopment requirement, right? And so this actually came from Durham, New Hampshire, which is a college town, and we had this era of development where people wouldn't increase the footprint, but they would change a one-story into a four-story student housing complex. And the claim would be we can't address stormwater on our site. We're not increasing impervious cover. Our footprint is the same. And therefore, you can't make us assist you with improving the downtown infrastructure. And so we put that clause in because if people are contributing significantly and, your stand to make certainly going from a one-story to four-story, including, the mixed land use, and you're going to be taking money for, student apartments. So you can't make the claim that you don't have money to do anything. So we added that as a way to, if you're significantly increasing and building out your property, then there's got to be some help that you can provide our aging and already vulnerable infrastructure that we're relying on to, move that water away. So, in stormwater, I think we're always playing catch up. We're always trying to mitigate things in the past, especially in the East Coast. We have a lot of historic development that went in without regulations. And now, as we infill and we build out our communities, those existing structures are increasingly vulnerable and increasing risks, right? To not only the water quality, but health and human safety when it comes to effectively conveying that water away. So we're asking the community, the development community, as you put resources into this community and into this town, please also help us build resilience and actually help protect your property and the economic services that you're going to rely on living in the downtown or living in the town. So um, there are examples of areas that have used that.
I see two more questions, and we'll try to get to these two last two, and then wrap up. Can you explain pre-development conditions? You mentioned it was natural conditions. What if it is a redevelopment site?
So yeah, so for a redevelopment site, what we're trying to avoid is, I'm redeveloping this property. I'm not going to increase impervious, and we're going to, we're so we're trying to take advantage of that opportunity to build resilience into the system. So I think this is one of the challenges I know in Massachusetts. If you're not changing and increasing the impervious cover, you're using the existing hydrology of the existing condition. And that means that you're missing opportunities. So, if you're redeveloping a property, all I'm going to say is that it's a good opportunity to take advantage of to help build resilience into your systems.
Our final question, are there additional benefits to watershed hydrology by requiring additional retention above these standards, like a 25-year or 50-year storm?
Hmm. I I don't know, Mark, maybe you can help me out with that. It's hard to say there isn't. I mean, is there a benefit for over infiltrating, like going beyond the watershed protection standard?
Um, I would say there is. There is benefit. What the watershed protection standard is really doing is for the new impervious cover to meet pre-development conditions. And we already have a lot of existing impervious cover that is minimally managed or inadequately managed or not managed at all. So we are we are trying to recover. Those subject to the TMDLs and the MS4 permits know how hard it is to try and retrofit control. So this is a way of kind of helping ensure, that resiliency, hydrologic resiliency in the community. So I think more is sensible. Whether you need to go to a 25 or 50 year, then you're really thinking flood control, and that might be further than you might want other ways to address those higher flows than all retention, because you're really talking much significant increase. And even in today's world, while we have a lot of intense storms, the beauty of the retention, and this comes back to that slope question, is this is cumulative simulations. Most of our storms are still small and deliver a lot of the load and a lot of the groundwater recharge. So retention is great because it holds the water. You might get a very high intensity that's, a 10-year frequency, but the retention practices can actually absorb a lot of that because they have storage. So
And Mark, we didn't get a chance to introduce you, but Mark Voorhees, formerly of EPA. And if you've used the performance curve, then you have Mark to thank. He really set the foundation for a lot of this work, and we're thankful that he continues to evade retirement by helping us helping us kind of give it some legs.
Thanks, Jamie. You're too kind.
And we're at time. Apologies for my audio is fading out. Not sure why that's happening, but thank you, Jamie. Thank you, Mark, for being here. Really excited to keep rolling this out and introducing it to the communities of the SNEP region. And we'll be providing the recording along with the links to the resources in a follow-up email in the next 1 to 3 days. Jamie and Mark, any final words before we log off?
Thanks for the opportunity and to the network for funding this great project.
Great. Thank you, everybody. Hope you have a great rest of your day. Bye.
Thank you.